Aspen Avionics has recently introduced a unique solution to measure and display angle of attack, or AOA. For those who purchase or own an Aspen Evolution 1000 PFD or MFD, there is no expensive or labor-intensive installation and calibration. No wiring, mounting, underwing sensors, or displays are needed. The Aspen AOA is a software upgrade to these boxes. Now, my purpose is to demonstrate the Aspen AOA in flight, and not to spend time citing statistics about the new acronym LOC, loss of control. The NTSB cited loss of control on its most wanted list. They determined it was responsible for 40% of all GA fatal accidents. So what is AOA? There are numerous explanations of what constitutes measuring and displaying angle of attack, so far be it from me to outline the technical details. Simply put, AOA measures the angle between the wing chord and the relative wind. And if too great, the wing will stall. For decades, the tried and true method for knowing when you're near a stall condition has been airspeed. And if you forget critical stall speed, there's the white arc on our airspeed indicator. But what speed does the plane stall in a 30-degree bank, 45 degrees, or 60 degrees? My plane will stall at the same AOA, but the indicated airspeed will vary dramatically. You'll see in a moment that AOA takes into account gross weight, bank angle of the wing, load factor, attitude, CG, and oh yes, airspeed. For this demonstration, I'll be using my A36 Bonanza, which has a 3-tube Aspen system. The advantage this gives me for the video is to showcase an isolated and enlarged AOA display. But single-tube systems have an automatic pop-up AOA right next to the airspeed tape in the attitude section of the display. Both the enlarged and single-tube systems work similar. The AOA has a single vertical band that is divided into a small blue band at the bottom, low AOA, cruise flight, a green band, normal approach AOA, a yellow band, caution zone, and the yellow-black crosshatch at the top, indicating the warning or stall zone. Both display types contain 2 pointers, the top one indicating a clean configuration, flaps up or gear and flaps up. The lower pointer indicates a dirty configuration, flaps down or gear and flaps down. I should note that the other currently available GA angle of attack systems do not take gear and flap positions into account. Hence, a less accurate depiction of the true state of the critical attack angle. The video is an electronic split screen to show the pilot's forward view and the 2 displays enlarged for visibility. It was shot with 2 GoPros, which were later synced together to get a single picture. Let's start with a normal takeoff and note that until we get sufficient airspeed to obtain lift, the pop-up AOA on the PFD remains hidden. Then it appears when needed. At my home airport, I rotate at 73 knots, the lower arrow just at the edge of the AOA stall zone. I let the airspeed build, getting to a 96 knot indicated VY speed as soon as possible, which on the AOA is the top arrow between the yellow and green bars, the sweet spot as I call it. I maintain best rate of climb by keeping the upper AOA indicator at the yellow-green transition. Now a normal landing. I'm always unlucky getting the windy condition between these trees, but rather than chasing airspeed, I keep the lower indicator in the sweet spot as close as I can, and when over the numbers, begin the flare. Upon touchdown, it's right near the AOA stall marker. Here is a slower look at it. Note the airspeed and attitude indicators bouncing around, but the AOA lower pointer staying right near the sweet spot. For a short field approach where I want to land using a minimum amount of runway, or an emergency landing situation, I'm going to allow the lower pointer to settle into the mid-range of the yellow caution zone, resulting in a slower approach speed, but knowing I will avoid a premature stall. Okay, first of all, we'll just do a power on. So flaps and gear are up.
Now, is that the top one or?
That's the top one.
Yeah.
Okay, and that showed it. Okay, and
now we're looking at the bottom.
right. And full flaps are going out. Now it's the bottom arrow.
Clermont County Traffic, Airback 89, medevac helicopter 3 miles to the east, 2,000 feet, we're crossing midfield to the west, Clermont.
And we've overshot the runway, so we're going to make it turn back to final. And we're going to go steep. You notice how the arrow goes up? Almost into the stall position, even though we've got good airspeed. Bonanza's on 1 mile final runway 4 at Clermont, full stop. This base to final steep turn, after trying to correct for overshooting the final approach course, is one of the greatest causes of low-level, loss of control accidents in GA airplanes. It's a dramatic demonstration on how the AOA indicates a pending stall, while the airspeed indicator shows 80 knots. GPS, weather in the cockpit, real-time traffic information, and I could go on and on how technology continues to improve the safety of our light plane flying. The Aspen AOA eliminates the barriers of costly installation and calibration, yet provides an extra margin of safety. There has to be a reason angle of attack is standard on military, air transport, and business jets. And yes, we have an airspeed indicator, and most planes have a stall warning. But here is an inexpensive method to provide an additional way to indicate a possible loss of control condition.